Hello, students, and welcome to the discussion on lines in a plane. And again, this is primarily a review session. This is a second video of the lesson, and this finishes out the notes with the word problem. And it says here that Maria buys a new car for $25,215. 3 years after its purchase, the car was appraised, or in other words, it was determined that it was worth $17,355. And if the car depreciates linearly, then we are asked to do these three following problems. First, write an equation that represents the value of the car as a function of years after it was purchased. Then determine how much it will be worth 5 years after its purchase. Then determine when the car will be worth 1/3 of its original value. So one thing to note here, and this is probably the most important part, is that the problem gives us that the car depreciates linearly. And linearly is important, okay, because it means that this function of its price can be fit on a number, on a straight line, on a linear graph, and we can treat this as a problem using slope and y-intercept. Okay? So let's try to answer the first question here, where it says, write an equation that represents the value of the car as a function of years after it was purchased. So we can define some variables. We'll say x is number of years after purchase. We can say that y is the value of the car, and that's going to be in dollars. Okay, and now what we need to do is write an equation that relates x to y. So again, linearly is important because it tells us that it decreases by the same amount every single year. Okay, so I'm going to make a note here that linear tells us that it decreases by same amount every year. Okay. So now what we can do is sort of find the average decrease per year. So I'm going to let M represent the decrease per year. Okay. So she starts out buying it, and in other words, we can create a linear function out of this using 2 points. Okay. So for number one, to answer this question number one here, we need 2 points. And the first point is going to be 0, 25,215, because when she initially bought it, 0 years have elapsed, and it's worth $25,215. Okay. The second point that we can use is 3, because 3 years after it was purchased, it was worth $17,355. So that means the decrease per year is really change in price over change in time. Move this over here. Change in price over change in time. So we can calculate this using the numbers that we're given, that M is equal to 25215 minus 17,355 over 0 minus 3. And once we do that calculation, it's going to be negative 2620. And so that means our equation will be y equals negative 2620x, because that's how much x represents, remember, the number of years. So it's important for us to keep our variables well defined here. Okay. So remember that x is the number of years since it was purchased, and y is the value of the car. So this basically means that for every year that elapses, that goes by, the car loses $2,620 in its value. Now we also need a y-intercept, or sort of the starting point, and that's going to be 25215, because at the very beginning, the car was worth $25,215. Okay? Now you can also solve. You can also use this equation plus b and solve for b. However, when you solve for b using this point, you're going to get 25,215. So this is the y-intercept here, because x is equal to 0. Okay, so this is the equation right here, and it's okay for us to write this as y and x as long as we define what the variables mean. Okay, so that answers the first question. So let's look at the second part of the problem now, where it says, how much will the car be worth 5 years after her purchase? And just remember, from part 1, we know that the car's function is y equals negative 2620x plus 25215. So 5 years after its purchase, 5 years after purchase, x is equal to 5. Okay? Since, remember, from earlier we defined that x is the number of years and y is the amount of money. So let me just rewrite this in here so we don't forget. It's such a critical thing to remember what our variables mean. So number of years since purchase, and this is the y represents the value of the car in dollars. So 5 years after purchase, we can just literally substitute in 5 for x and evaluate that expression on the right side there, and that will give us $12,115. So 5 years after we buy the car, after Maria buys the car, it will be worth $12,115. And then number 3 asks, when will the car be worth 1/3 of its original value? So this time, it's important to keep in mind what it is that we're solving for. Okay? In number 2, we were given the number of years and we were asked to solve for the value of the car. This time we're given the value of the car and we're asked to solve for the number of years. In other words, it's asking us when will the car be worth 1/3 of its original value. So we can express it this way, in saying that the original value was 25215, and we want to know how long it's going to take for it to be worth 1/3 of that. So that's going to be $8,405. So it's asking how much time is going to go by before the car is worth $8,405. So we can take this number and just substitute it into the value for y using our original equation here and solve for x. So we can subtract 25,215 from both sides, and that gives us negative 16,810, which is equal to negative 2620x, and then divide both sides by negative 2620, and that gives us approximately 6.41 equals x. Actually, it's closer to 6.42. So it's approximately, and so we can say that it's about 6.42 years, or 6.5 years, is how long it's going to take this car to depreciate to 1/3 of its original price. And what I'm going to do now is show you how to do this on your graphing calculator. so that you can use that to double check your answers, or in the future if you did want to answer questions by graphing, you can also do that as well. So I'm going to erase some of this and show you how this is done on the TI-83 or TI-84 graphing calculator. Okay, so we're going to revisit this equation right here, y equals negative 2620x plus 25215, and I'm just going to hit y equals. Make sure that all these plots are off, because if they are on, they could really mess up with your calculator. And we can type in negative 2620x plus 25215. And before you graph, let's make sure our window makes sense. Now the window here, the x value, keep in mind the x value is the number of years since its purchase. So it's going to start at 0, and it's going to go, we'll go, let's say 10 years. Okay? We can definitely go further than that. Scale, it's going to increment at one step at a time. The y min, so remember that y represents the value of the car, which is the smallest it can be is $0, and the highest can be is that the highest that it can be is 25,215. But I'm just going to go a little bit higher than that, just so that the graph is easier to visualize. So I'm going to go to 30,000, and I'm going to increment it in $5,000 increments. Okay? And once that's on, you can hit graph. And you can see the graph that this graph is decreasing, because every single year the car is losing its value. And if we want to know how many years, how much it's worth 5 years after the purchase, you can just hit trace and type in whatever number you want, 6. So your calculator is asking you to type in a value for x, and it will give you a value for y. So we can type in 5, and you can see that it is $12,115. Okay, so that's the answer that we got algebraically. And for part 3, where it's asking how much will it be worth in how long will it take for it to be worth 1/3 of its price. Okay, so it's asking how long will it take until the car is worth 1/3 of its original value, and we know that 1/3 of its value is $8,405. And this time we're given the y value. This is the y value because it's the worth of the car, and we're asked to find the x value, in other words, the number of years. And so in your calculator, you can go into your graph here, your y equals button, and just type in 8405, and this will graph a horizontal line. Okay? And this intersection point represents the point where the graph of the car's value equals the graph of 8,405. So we can go into the intersection, and you hit the second button, and then the calc button or the trace button here. Go down to intersect. The first curve, and you can see here at the top, it says y1 equals negative 2620x. That's the first curve that we want to find the intersection for. The second curve, we want to find the y2, 8405. And guess means you move the cursor as close to the intersection as you think it is. You can see it blinking there. Hit enter, and you can see that the answer is, maybe I should zoom in a little bit here. You can see the answer comes out to x equals 6.416, which is about 6.42. And that's the exact same answer that we got by solving this algebraically. So there's two ways you can definitely do these problems. One is algebraically, like we did earlier, and the other is by graphing. Now I have to make sure that you understand, whenever you're doing graphing, you're solving by graphing, you have to show the graph, you have to label the graph clearly and precisely, and you have to explain what these lines mean and what they represent. Otherwise, the graph is not really meaningful at all. Okay, but this is another option for you to use if you want to solve these problems graphically.